I am JP Escarcega, an incoming junior to the STEM Corps, and for the 2015 STEM Summer Project, this is it. I suppose before I go into any Edison moments or rollbacks, I should first describe this instrument in itself. So as you can see, there's a wooden base. It's drawn turquoise, and the instruments playing are going to be metal pipes. The mechanism for the instrument, the mechanical part, would be that of these underlying points. The transfer of energy when I strike this nail, which then hits this bolt, causes the bolt to move and then hit the pipe, which then makes a noise. The inspiration behind this entire project, or as they would say, the inspiration behind the muse, would be this equation A equals F over L squared. So for a pipe, and concerning its sound, for a pipe, the constant A is equal to the pipe's frequency, hertz, divided by the length of the pipe squared. A is equal to F over L squared. What that means is that each different length of these pipes is going to give you a different sound, a different tone. That hertz sound that it gives will give you a certain tone. Hence the entire G, A, B, C, these all give different noises. It's allowed me to put this down and break it down to a science. Alright, now is the time for Edison moments. I suppose the first Edison moment that I'll go over is the calculations that I had to make. So naturally I had to make a calculation for each and every pipe, each and every hertz and its relation to the length of the pipe. Turns out that when you make the calculations, as should be expected, there weren't whole numbers. I'd get sometimes ridiculous lengths such as 10 inches and 53/64 to mark out on a pipe. The problem with that is when you have the saw blade and are cutting that pipe directly, it's not going to be as accurate. So what I ended up finding out is that I cut my pipes a little too low, trying to be accurate with the lines that I'd make around them to mark them, such that the frequency would be changed and the note would be different itself. This was hard to swallow when I noticed that, because it suddenly meant that everything that I was doing was wrong. I had to completely rethink my process of cutting. What ended up happening in the end was that I had to cut over the mark that I made of the pipe, such that I could specify by my calculations ranges, spectrums of notes, spectrums of hertz, spectrums of length that I could cut just to get the right note. G of 8 will, range over different lengths, and that's exactly what I was able to do on that part. Another piece, maybe the bigger piece and the bigger second Edison moment, would be the design of it. So at first I had this design. Naturally I wanted to get each of these pipes and put them into these holes. I wanted to have my mechanical piece right here such that I could twist it and hit the pipes each. And I'd have 4 circles such to represent the 4 verses of the entire instrument. And that didn't work out for me. The pipes wouldn't stay in, all sorts of other things wouldn't happen. I couldn't figure out how to get the mechanical instrument in. I was bumped. I didn't know what else to do. This came out of much thought, but it was maybe the biggest Edison moment I could have. I first couldn't understand how to even get a mechanical piece going in here, and then secondly, the pipes would even fit in there. That was the big breakthrough that led to this. Next, what we'll be going through is the construction process of this, which will just be highlighted by pictures and videos. And now, for the final part of this video, I'll be going over playing the Happy Birthday song. Alright, I'll begin.